Okay, we stop for a while. We go for our lecture first, okay? Because our schedule is quite tight now. Next week is the Gawai week, so we're not going to have our lecture. So I do a bit of rearrangement of our lecture today. Give me a minute. So we supposedly to have chapter 9 today, but we after discussion with after discuss with Dr. Izatu, we decided to swap the chapter 9 and chapter 10. So today I will cover chapter 10. Can you all hear me? Okay.
Yes,
So
Doctor.
today I will cover, yeah, okay. I will cover chapter 10 today. Then let's see if we can finish everything or not. If we cannot finish everything, then we will see what to do. But chapter 9, definitely we're going to use the video for you to learn chapter 10, chapter 9. Okay? Okay, let's do this.
Doctor, don't mind me asking. Next week, the holidays will begin on Tuesday and Wednesday, right?
Tuesday and Wednesday, yes.
All right.
Yeah. But because Monday, the following Monday is also the public holiday. So we have been receiving a lot of requests from students to cancel the class.
Oh, really? Okay.
Yeah, because it's the Agong birthday, right? If I'm not mistaken.
Agong's birthday is on the 6th of June.
Yes. So we're going to have the Wednesday, Thursday as a public holiday, then come back one day for Friday, then Saturday, Sunday, Monday. So Gawa is something big here. So that's the reason why we receive a lot of requests to cancel our class for Friday.
Okay, okay.
Yeah, so we have to give way for Gawai. So I think tutorial is fine. Tutorial is fine. So that's the reason why we want to swap a little bit so that because chapter 9 is relatively easier compared to chapter 10. So chapter 10 also cover a little bit of chapter 9. So that's the reason why we decided to swap chapter 9, chapter 10. So you're going to learn online by yourself for chapter 9, then I will try to cover chapter 10 today. Okay?
All right. Thank you, Doctor.
So can you see my slide?
Yep.
Okay, let's go for chapter 9. Chapter 10, sorry. So next week, tutorial for chapter 10. Okay, it's okay, we can discuss about this. Okay, so because chapter 10 is very lengthy, so I try to come up with a way to explain to you that how to do hypothesis, what is the things that we need to know about hypothesis. Okay, so okay, now I will off this thing, then we'll come back to this slide a little bit later. So once you can understand the concept that I tried to convey to you, then I think you shouldn't have any problem to understand to read through this slide as many as 65 pages. Yes, 65 pages here. So we will come back to this a little bit later. Okay, so I just want to show you the concept. When you understand, then that's fine. Okay, chapter 10. Chapter 10 is talking about hypothesis. So what is hypothesis? Can anyone try to answer? So actually, do you know what is the purpose of us study statistics? A lot of students cannot understand why we need to study statistics actually. You know that, okay, we use statistics to do analysis. Then what kind of analysis is that? Okay. So as I told you before, statistics is talking about, I have to do the recording. Statistics is about how do we collect the big data to analysis big data. So big data in the concept here is a population. Like one of the example that I explained to you, that if I want to collect the data from whole over Malaysia to study what is the average expenses of each of every household in Malaysia. So the population is all the household in Malaysia. So this is called population. Okay, so it is kind of impossible for us to conduct the survey throughout Malaysia to check all the what is the average expenses of each of the household, right? So we will go to the smaller scale called sample. Okay, how to collect sample is another branch of statistics. How to do the proper random selected sampling. That's another topic. Okay, but we're not going to cover here. So now is that after I have the sample, I hope that the sample is good enough to represent the population. So there's a lot of hypotheses for us to check, to claim, to test, and to predict whatever claim that we do is correct. We try to do as much as that. So people will say that actually statistician is like fortune teller, which is true. When you don't have a lot of data, but you hope the small data set in hand can represent the big data. When you know the data in the big scale, you can do a lot of analysis. That's how people can attract the investor to come to invest when you have a very good set of data. Okay, so how can we do that? How can we manipulate something? How can we do analysis with a small set of data? So we can only do by using statistics. So they come with the hypothesis testing. Okay, your chapter 10. Okay. In your hypothesis testing, you're going to do hypothesis testing for 3 parameter only for 3 statistic parameter. So all these 3 parameter, they're having the same, exactly the same procedure. Okay, I'll tell you what. So the first one is the proportion. Can someone tell me what is proportion already? Hello. Okay,
Part of the data.
part of the data, no. Okay, now everyone, can you explain to me what is mean? What is mean? The average
Mean is
values,
the
correct?
average.
Yes, purata, right? Do we have international students here? Okay. You know the population and the sample, we have different set of statistics. We have different set of mathematical symbol to represent each of the parameter, right? Okay. For example, the standard deviation for the population, the symbol is sigma. For the sample is small s. Okay. The mean for the population mean we normally is represented by the mu. If it is sample, then we represent at the x bar. So for this, you have to know it first. Once you see the symbol, you know this value is represent population or represent the sample. This is very important. Okay. So in this chapter, we only do hypothesis testing at these 3 things. Okay, let us get to know this first. So everybody know what is mean. Mean is average. Very good. Okay, mean is average. So what is proportion? Proportions means that percentage. For example, okay, example of the proportion. 3 students out of 4 are wearing glasses. This is proportion. 75% of my students have their PTPTN study loan. This is proportion. So now, when you look at this, right, is this mean? Is this average? Can I put this as an average or not? Cannot, right? Average is talking about average final exam marks, average height, average expenses, average IQ score. It's different. Average means that every single student have a values, and then I want to add up all the values divided by the number of students. So that is average. When we're talking about average and the mean, they are referring the same thing, but it's different than the proportion. So proportion is something like this. So are you clear now? If you're clear, type me proportion. If you're not clear, type me not clear. Okay, so every student know already what is proportion. So in this, we only have three things. The first is to test on the population proportion. All this hypothesis testing is assuming that we can predict the population parameter. So what is the population parameter that we have here? Proportion, the one that we want to test, proportion, okay? The second one is the mean. Mean is one of the most important parameter that we always do testing, the mean. Okay, then the case number 2 and number 3, there's a bit similar. They all always want to test on the population mean, but then some of the cases where the population standard deviation is known, the other one is unknown. If it is known, it's easier. If it is unknown, we have to use another set of the table to assist us. Can you understand me? Yes. Okay. I guess you all learned before, right? Hypothesis testing. During your secondary school, your Form 5 or Form 6 or your Asasi, you always write the H now and the H alternative. Correct not? Then you will write a lot of this mu equal to 0, mu not equal to 0, and then you draw the chart like this, and then you do the calculation. Okay, now you all learn already. So I don't need to teach already, right? Okay. Okay, so I want to ask you, do you actually understand what are you doing or not? Do you actually understand why do we need to do this, and why up to where I can do this testing? What does it mean? So how far the evaluation that can be carried on can be explained here? I don't quite remember. Not really. Okay. Those answer no mean what? That means you didn't learn this before?
Doctor, I learned, but I don't know the purpose, and also I only know it for gaining marks, that's all.
Okay. Like Wong Guan Ting. You said no means what? Like Angeline. The no means what? Never learned before, or you don't understand why all this? Don't understand. Okay. Okay. So today I just I think I never learned. Impossible lah. Form 5 other I think Form 5 MX already got. Unless you didn't take your MX.
Form 6 only, Doctor.
Is it? Form 5 don't have
If I'm not mistaken, I didn't have that in Form 5.
Oh, okay.
We don't have that in Form 5.
Even in MX?
Yes.
Oh. Oh, you all learn this in Form 6 and Asasi.
Yes.
Anyone from Asasi here? Okay, never mind. Let us go through it again, okay? Just assume that you didn't know anything. Okay, so now we try to learn something. Okay. Okay. Hi. Who is the one that talking? Okay, now you have to remember our M is population. But what you have in hand here is sample. Okay. Our M is that I hope that the sample mean is the same as the population mean. I hope that the standard deviation, sample standard deviation is the same value as my standard deviation from the population. So this is our M. But in reality, actually, it's not the same. So we want to see how far is it, and then we keep on doing predicting. So we come up with the hypothesis testing. So this chapter 10 hypothesis testing, I can say that is the lowest grade of hypothesis testing. It's a very, very basic and fundamental method to do hypothesis testing. Hypothesis testing means that now you have two claims. You know, two claims. For example, you have team A and team B. They are debating. Okay, they debate. Okay, team A said, I think the girl can earn more. Okay, their salary is more than the boy. Then the boy team said, no, we think that the girl cannot earn more than boy. Okay, Now the statistician will come out that, okay, we take these two hypotheses and then we do hypothesis testing. So that is the claim. Hypothesis means claim. Okay? Hypothesis testing, remember, cannot test a lot of things, but it's very, very basic and fundamental. So you just need to know the procedure when you have the fundamental. If you really have interest in statistics, you can go further to do analysis, to learn more technique, how to do the proper analysis in future. Okay? So there's a lot of limitation in hypothesis, but this is fundamental. Okay? So now, you know what is the meaning of the hypothesis already. So the hypothesis, right? Today, in this chapter 10, we're going to do hypothesis testing for either this one, proportion, the second one, and the third one. The procedure is the same. Okay. So I give you a rough idea what is the procedure. Okay. The rough idea is that you have to write the claim first. Okay. So why I need to do hypothesis testing? Because there are two teams that they're debating or something. So that two teams, they have own statement. So I have to put that two statement, we call it as a claim, as a hypothesis testing. So this hypothesis testing is either to test the proportion or to test the mu in this case. Because mu got two scenario, right? Two condition. One is either the standard deviation is known or unknown. Okay, so two cases. So you only test on this. Okay, so after I have this, then I'll look at the claim. I will start to draw the bell shape already. I will draw the bell shape already. So that's the why you have this one tail, two tail thingy. Okay, then I will do a set of testing. I have a formula. Population got their own formula. This mu with the standard deviation got their own formula. This mu with the standard deviation unknown got their own formula. But the procedure is the same, just doing the different formula only. So I have a formula, then I calculate. I try to calculate. Then I come up with a values. That's called A. Okay. So this A is in Z, in a Z form, Z score form. Then I will see this A is where? Is here, is here, is here, is here. If your A Z score is 4 under shattered area, then that means we reject. If it is 4 in this white region area, so let's say here, then we fail to reject. Okay. Why I said this hypothesis testing is very basic, because this hypothesis testing, you can only draw conclusion on your null hypothesis. You cannot say anything on the alternative hypothesis. You can only either reject or fail to reject null hypothesis. The whole story is like this. I give you the trailer first. Okay. So far, so good. If you're good, so the procedure is that the first, I will write this hypothesis first. Second, okay, I will start to draw this. This is second. Number 3, I will do the testing. Number 4, I will see where is it. This testing value, where to put. Is it at the reject region or fail to reject? Then number 5, we draw conclusion. Can you all hear me or not?
Doctor, just now after you said the conclusion, did you say anything after that?
Okay, I say after the conclusion. Okay, so can you all see my whiteboard now?
Yes, now can.
Okay, so after my conclusion, I said the number 5 is conclusion. So far you all understand the whole story first?
Yes, doctor.
How about the rest? If you can understand, tell me understand. Okay. So this is the 5 major steps that we're going to have. Okay, so now, I proceed, okay? So now the first one, we're talking about the hypothesis first. Because the hypothesis, you need to know how to write the hypothesis. Okay, the one. Okay, so we always have this H noun and H alternative. Sometimes my students, they cannot do hypothesis testing, but still I will ask them to write your hypothesis testing, because if you get your hypothesis testing correct, then definitely there's a mark. Okay, now let's say the claim said that, okay, the claim said that, okay, I see one of the example, okay, one of this. Okay, the claim said that the average amount of the soda in all the can is equal to 12 ounces. So, okay, they said the amount of the soda in all the can is equal to 12 ounces. So that's it. Mu is equal to 12 ounces. Okay, so this is the claim. How can I put this claim into here? Okay, the first tip is that in the null hypothesis, the sign is always equal. Okay, as I said, the hypothesis testing is talking about debating about 2 claims. Okay, so if I said that the mu is equal to 12, the debating the opposite side must be the mu is not equal to 12. Correct? This is case number 1. This is case number 1. Okay, the case number 2 is that if I said mu is greater than 12, so what is the other one? Everyone? Mu is less than 12. Correct? Number 3. If I said the mu is at least or greater than 12, what is the other one? If I said the mu is greater or equal to 12, what is the other one? The answer is the mu is less than 12. Okay? Okay. Now, so now we look at all these examples. We want to see each of the case. What can we put? Where do we put? Okay. Now, okay. So I want to put this. Let's see. Let me give you another good example. Okay. Okay, the first tip is that in your null hypothesis, your sign is always equal. We look at the first one right now. Okay, the first claim saying that the main claim said that the mu is equal to 12. Okay, so because the equal sign is here, this will definitely go to your null hypothesis. So mu is 12. So the alternative hypothesis have to be mu is not equal to 12. Okay, so far so good. Now we go to number 2. Okay, you see the B here. Okay, this is the main one. Okay, can you see any equal sign in these 2 claims? Can you see any equal sign in these 2 claims or not? Okay, so in this case, because your null hypothesis must be putting equal, you cannot put any mathematical equality sign except equal. So for this case, the mu is always equal to 12. Then we look at the first claim here. The first claim here is this, is greater than 12. So your alternative is mu greater than 12. Can you understand me? Okay, we do the third one right now. Okay, we do the third one. Okay, the one is this. So can you see any equal sign here? Can you see any equal sign here? See. You see equal sign here. There is an equal sign here. Correct? When this is the case, okay, your mu for the null hypothesis is still 0. It's still equal sign, so it's equal to 12. But alternative, your mu here is less than 12. Understand me? So it means that we always look at the equal sign put into the null hypothesis, then the alternative will be the other one. So far, so good. Okay. Okay. So there's a very common mistake that from the students, based on my experience. When you write the null hypothesis and the alternative hypothesis, we are debating the claim, correct or not? So all the mathematical terms that you write in the hypothesis have to be in the population form. What does it mean? It means that sometimes when the question asks you about the mean, the student will write this. What's wrong with this? For example, this. This is wrong. This is wrong. Why? Because this is all the hypothesis testing is for us to do the claim that the value that I found is equal to the population one. So we must change this to mu. These two are all mean and this. They are all talking about mean. But this comes from sample. This comes from the population. Can you understand me or not? If you can understand, type me null hypothesis. Okay. I repeat, in a null hypothesis, the mathematical sign must be equal. And the alternative hypothesis, there is no sign for equal. Cannot have the sign of equal. It can be greater, it can be smaller, or it can be not equal. Okay, so this is the first tip. Okay, now you understand already? Then we can go to the second one is talking about the bell shape. Okay, now talking about the bell shape. The bell shape is always, because the bell shape will give you the whole idea of what tail you are. Okay? So how do we see that it is, because there's only 3 types, you only have 3 types here. You either have this 2 tail, okay? You will ask me, Dr. Sir, how I know what is this? What value is this? You just need to agak-agak to draw the tail first, okay? You either is 2 tail, okay? Right tail, or the left tail. How do I see whether it's 2 tail, right tail, or left tail? We look at our alternative hypothesis. Okay? We look at our alternative hypothesis. If it is not equal, then it's 2 tail. If it is a greater, okay, pointing to the right is right tail. If it is less than, the pointing to the left is left tail. That's it. Why? Because as I said, hypothesis testing, we can only draw conclusion of to accept, to reject or fail to reject null hypothesis. We cannot make any conclusion on the alternative, but alternative can help you to define the region to reject. So we're looking at our alternative hypothesis to decide which type of the bell shape that we're looking for. Okay, so far so good. If you are good, type me bell shape. Okay, now I want you to go back. I will stop sharing. Okay, I will stop sharing. Then I will want you to go to your slide. Okay, go to the slide. My slide. Where's my slide? Okay, I want to give you one example. Okay. I want you to go to the slide 17. Let me see. This is slide 16. No, this one. Okay. My slide number and your slide number is slightly different. Can you go to, I want this example, okay? So, okay, now you spend about 10 seconds to read through, and then when you're done, type me done. I don't have the material for chapter 9 and chapter 10 yet. Oh, really? Okay. Okay, then it's okay. They'll see from the screen. Okay, later I will, maybe Dr. Izatu forgot to make it visible for you all. Okay. Okay, everybody go, just look at my screen. Look at the screen and then spend about 10 seconds to read it through. When you're done, type me done. Okay. So this is one of the method. So add sort, this case, add sort method to have the gender selection to increase the likelihood to have a baby girl. Okay. They want to have a baby girl. Okay, baby girl. Okay. So normally, if we're not doing anything, okay, or if we said that it's not effective, then we'll say that actually to have a baby boy or baby girl, the chances is 50%, right? 50-50, right? 0.5, 0.5. But this preliminary result from a test that on a 14 couples who gave birth, they have 13 girls and 1 boy. Okay, so you tell me, this is proportion or this is mean? Is this proportion or mean? They want to have, talking about the girl. Now they have 14 couple. Oh, this 14 couple, they have 13 girls. So this is talking about proportion, right? So use the given claim and the preliminary result to calculate the value of the test statistics. Okay? So this is sample, no? This is sample. All the value here is sample. This is all the sample data. Okay? So if we are saying that the sample proportion here is 13, okay? The sample proportion, okay? Okay, the proportion here is 13 out of 14, correct? I only have this data. So I hope that this also represent the population proportion. Alright? How do we write the sample proportion? Is the P with a hat. This is just the P. Okay? I only have this. This is sample. So you understand, huh? Okay, now. So how do we write the null hypothesis and also alternative hypothesis? The first step that we need to do is to set up our null hypothesis and our alternative hypothesis. Correct, not? Okay. Correct. Everyone. Can you roughly do how to write out the null hypothesis and the alternative hypothesis? So the sample, this is talking about giving birth. to have the gender selections. So if we're not doing this spatial add sort method or whatever, okay, the chances for you to have a girl is 50%. But now they claim that by using this, I can have more chance to have the girl. More chance to have a girl. More chance than what? More chance than 0.5. Correct not? Correct not? Okay? So how do I write my hypothesis? My hypothesis is to test the proportion. To test the population proportion. So my population proportion used to be 0.5. Okay? But now they said by using this add sort, I can have more higher chances than 0.5. So it's the P greater than 0.5. So far so good or not, you all? Okay. So far, okay. So the first step I already done. I already have my null and the alternative hypothesis already. So I want to draw my bell shape. Okay. So what tail is this? Two tail, right tail, left tail. Right tail. Why? Because the alternative is pointing there, pointing at the right side. So it's the right tail. Okay. Done. Okay. So I'm done already. So I rewrite everything. My null hypothesis is my P equal to 0.5. And then my alternative hypothesis is P greater than 0.5. And then now I draw my bell shape here. So if I refer to my alternative hypothesis, I have this right tail, right tail. Okay. Now, can I do my testing already? We done the first one, the second step. So now we want to do the third one. Later we'll come back to the second one. Okay. So the third one is to do the test statistic. Test statistic is from the sample data. Okay? From your sample data. So the formula is given to you. You will have your formula in this. Okay? So now I share with you the formula first for the test statistics. Okay. The test statistics formula. Okay. The formula for the proportion test statistic is Z equal to sample proportion minus the population proportion divided by the square root, the P and Q divided by N. As simple as that. Okay. So by using this, I already can calculate what is my test statistic. Test statistic is equal to, if we look at this, so just now is 13 over 14, correct? Not? 13 girl out of 14 birth minus the 0.5 divided by the square root of 0.5 power of 2 divided by n. So what is your n here? N is 14 birth. Can you quickly calculate for me? Can anyone do the calculation for me? $3.207. Any more? 3.207. Okay. So you all said it's 3.207. So what is this 3.207 here? So this 3.207 is talking about the Z-score of the sample data. The Z-score, again, I repeat, this test statistic is to find the Z-score of the sample data. So 3.207 is where? Okay, 3.207 where? Is it here? Is it here? Is it here? We don't know. Okay, but you need to calculate your test statistics. Okay, I repeat, test statistic as is the Z-score from the sample data. So when you have the Z-score is equal to 3.207, can you find the probability? Can you read from the table what is the probability for me? Everyone, please. Read from the table and let me know what is it. No? Try again. If you read for 3.07, so you are somewhere here, right? You see that the area is a 0.9993. That's me. You are covering this. Correct or not? No, I want this area. I want this area. Okay? Correct. So this is 0.0007. How many is 0? 1, 2, 3, 4. Yes. Okay. Okay. So that means you must be somewhere here. Why? You must be somewhere here. Why I say so? Because you remember that the first tutorial or first lecture that I give it to you all, I mentioned that the common rejected population is 0.05. Do you remember that your tutorial chapter 7, they'll ask you, is this event usual or unusual? Do you remember this? Normally, we said the event is very unusual when the probability of that thing happen is less than 0.05. Remember or not? In your tutorial 7, we always ask the usual or unusual event. How do we make conclusion of this? Is the probability of this event to be happen is less than 0.05? We use 0.05 as our benchmark probability. Is less than 0.05 is very unusual. Remember? Okay. So most of the case is like this. If they don't give you anything, if you see the chances of this thing happen is 0.0007, which means that the chances of this thing happen is very rare. So normally we will reject it. We will reject the hashtag. Okay. Highly unusual. Okay. So no, actually I just want to tell you that when you do the test statistics, after you do the test statistics, you can always find the probability. And this probability, we call it as a p-values. Okay? This is we don't do this conclusion yet. Okay? Conclusion will come a bit later. Okay. So you have this test statistics. So this test statistic is a z-score from the sample data for you to do the comparison. After you have the z-score, definitely you can transform it into the probability. So this is a probability. In statistic hypothesis testing, we call it as a p-values. P-values. Okay? They are actually the same thing. Just like I always tell you, ringgit and USD, they are the same thing. Just one is the z-score, one is the probability. In hypothesis, this probability is called p-values. So far, so good or not? Okay, so we're done with the procedure 1, 2, and 3. Now we want to go to number 4. Okay, so what is number 4? Okay, number 4. Then I have to change the slide. I have to go to another example for you. Okay, we give another example. Where is it? One more example. Let me find another example. Okay, you go to, you don't have the slide, huh? Sorry, I forgot you all don't have the slide. Study address. Okay, now I want you to spend about 10 seconds to read this example. Then when you're done, you tell me you're done. Okay, whoever that done, can you try to write the hypothesis? Can you try to write your hypothesis? Okay, we roughly write it out. Okay, so this study is talking about the pregnant woman can correctly guess the gender of their baby. The study showed that 57 out of 104 pregnant women correctly guessed the gender of the baby. Use this sample data to test the claim the success rate of the search guesses is no different from 50%. Okay, use a 0.05 at a significant level. Okay, now what we learned so far. Number one, we need to write our hypothesis. Okay, the hypothesis is talking about the proportion, right? 54 out of 104 definitely is not average. Definitely is not talking about the mean. This is talking about the proportion really. Okay, so now they say use this sample data to test the claim that the success rate of such guesses is not different, is no different from 0.5. Okay, no different. So the P is equal to 0.5, no different. So the opposite one is a P not equal to 0.5. Okay, so I want to put this as my null and my alternative hypothesis. So I'll put it in. P is equal to 0.5. P is not equal to 0.5. So when you read back the question itself, you know that they are emphasized as no different from the 50% success rate. So this is the original claim. Later in your conclusion, you need to answer this question. You need to answer, you need to reply and make conclusion of this statement. So you need to know what is the original claim. Okay, we will say that, oh yes, it's no different, or no, there's no different. We don't talk about the alternative hypothesis. Okay, when you have this when you have this null hypothesis and the alternative hypothesis already, then the second thing is to draw the graph. So this tell me that we are having two tail. Okay, two tail. But what is this number? Everything? Never mind, just leave it first. Okay. Now, when I know this is second already, we're done. So when you know already all these things, you can actually do your test statistics already. The third one is the test statistics. I already tell you the test statistics P. The formula is the P hat minus the P divided by the square root of PQ divided by N. So everyone now do this calculation for me. Okay. So you have your sample proportion is 57 out of 104. 57 out of 104. Now, everyone do this test statistics for me and find me the values. 0.9806. 0.9806. Correct not? Anyone get any different answer from this? Okay. Now, can you tell me what is the p-values? You have this is z-score, right? So this is z-score already. So what is the p-values? Anyone? Zero point 0.8365. Okay, I do not know the answer, but I'll leave it there. Okay, so from here I can find this one. Okay, now we go back to this question again. Okay, use the sample data to test the claim that the success rate of the search guesses is no different from the 50% success rate as expected with the random guess. Use a 0.05 significant level. So what is a significant level here? Significant level in a mathematical term is called alpha. Okay, he said alpha is equal to 0.05. Okay, this is to give you, in a question they give you, this is your benchmark. I give you benchmark already. This one is from sample. All this come from sample. This one is benchmark. You know what is benchmark or not? For example, right, when you drive your car at the highway, they said you cannot drive with the speed more than 110. So if you when you speed your car to more than 110, you will get a summon. Correct? Not? So this 110 is a benchmark for us to refer. And then why 110? You have to ask them why lah. But this question, they said that use a benchmark of 0.05. This 0.05 actually is referring to the probability. Just now, I asked you to draw the bell shape already, right? The second step, you draw the bell shape, and then we'll decide how many tails of them. Correct, not? Okay, how many tails of them? So, in this case, it's two tails. Two tails. Yes. Okay, I'll explain this a little bit later, okay? So this is two tail. They said we will reject. Actually, this 0.05 means that they want to reject the bias data of 5%. Okay, all the data that they have, they want to buang 5%. So when they buang 5%, because two tail, so this 5% have to divide up at two places. So this is equal to 0.025. This one is equal to 0.025. Okay, when you add it up, it's equal to 0.05, correct? Not? Okay, when this area is 0.025, 0.025, what is the critical values here? We call it critical values. What is the critical value here? Can you read from your table? When the area is negative 0.025, what is the z-score there? Is 1.96, correct? Okay, so this is 1.96. Okay, this is equal to 1.96. When the area is symmetry, so this is negative 1.96, here is 1.96. One is positive and one is negative. Okay, now this is benchmark. Okay, like the police want to give you the summon, they will use this to check on you. Okay, so this 0.05 and this positive and negative 1.96, they're actually the same thing. One is z-score, one is probability. Okay, same value, carry same value. Okay, so now we want to compare this value with these values. This is the sample data, one is the benchmark given by the questions. Okay, so in the test, in the sample here, you got 0.9806 and 0.8365. You should know which one to compare to which one. 0.9806 should compare with the plus minus 1.96 because they are both z-score. Can you understand me or not? So if I put this 0.9806 here into the bell shape, it will be somewhere here. Correct not? Correct?
Yes, doctor.
Not at the shattered area. So as I told you, if they are not at the shattered area, we cannot reject the hash down. Do not reject. So we only have two conclusions. Either we reject the hash down or we do not reject. So when it fall under the shattered area, this is called the rejection region. Okay? But because it's fall here, so this is cannot reject lah. Okay. So this 0.9806 here is compared with this plus minus 1.6. If you use the p-value here is 0.8365. Can you see where I circle? How to compare this? This is to compare with your alpha, your significant level. 0.8 compared to 0.05. If it is not less than the alpha, we cannot reject. Can you understand me? So this is the stage number 4. Step number 4 to do the calculation. After that, we compare. Okay, before we draw conclusion, okay, I just do a summary for you. When you have the test statistics, the one that I give you the formula, okay, you will calculate the Z equal to a formula. With this formula, you can find the P. We call that is a P values. Okay, this is from sample. Another one is from your questions. We assume it's from the population. Okay, they will give you the alpha. This is called the significant level. Just the name, significant level. Okay. Then with this, you can find, as I always change the Z score to the XX to the Z score with just one simple formula, right? So this thing also the same thing. My alpha is very ugly. Okay, this is the alpha. Then with this alpha, I can always find the critical values. This critical values actually is in a Z score form. Okay, so you look at what I wrote. I want to write here. Okay, look at here. This compare with this because they are both in Z score form. This compare with this, and then this compare with this because they are both in the probability, or we call it area in this case. This both in the Z score. So far so good or not, everyone? If you're good, tell me good. If you do not understand, tell me which part you do not understand. Okay, now you know the conclusion that we cannot reject because it's false somewhere here, right? So we cannot reject. So when we cannot reject, we have to look back. Now we already done already. We want to make conclusion. We want to make our decision already. So the first thing that you must say, is that we must make our decision. Our decision is we fail to reject. You can only talk about hash now. You cannot talk about alternative. You can only talk about the hash now. Say either you reject or you fail to reject. There's no other terms because you don't have enough information for you to analyze alternative. You can only make conclusion on your null hypothesis. Okay, clear? After you make the decision, then we need to draw the conclusion. So what to conclude? Conclude is always to answer the question. So this question is referring to this null hypothesis. Okay? Not all the time that your conclusion statement is referring to the null. Sometimes it is the alternative because we have to look at the equality sign, right? When the equality sign is not there, then we cannot. Okay. So the question is asking about no different from 0.5. No different from 0.5, that means equal to 0.5. That means the statement is at the null hypothesis. So we need to answer this statement. Because we fail to reject, that means we accept, right? So we just say that there's not enough evidence to support the claim that, because this is correct, because we fail to reject, that means this claim is correct. So we say we have not enough evidence to support that the claim. We have enough. Okay, not to say not enough. There's enough evidence to support the claim that the gas is no different than this. Can you understand me or not? So we have to say there is enough evidence to support what? To support the claim of this. So far so good or not? Can you understand? If you can understand, type me 1. Okay. Okay. So if you can understand this, I actually finished everything already. Okay, now I want to go to my whiteboard so that you can understand. I can talk about a bit more about this. Okay. Now you see my whiteboard? You can see my whiteboard, right? Okay, very good. Okay, so as I explained to you that this chapter we only test on 3 things. One is the proportion. Second one is the mu. The third one is also the mu. Why mu? Okay, means that in one case, the case is that the sigma is known. The other one is the sigma is unknown. Only this. Okay, what makes a difference? As I tell you that the procedure is all the same. The first one is to define the null and the alternative hypothesis. The second one is to draw the bell shape. The third one is do the test statistics. What's make the difference of this? Their procedure are all the same. The difference is only the test statistic formula. That's it. So proportion have their own formula. This one have their own formula. This one have their own formula. So you just need to make sure that you have been using the right formula to answer the hypothesis testing, then you are right. So far, so good? Okay. I know that you don't have the formula with you. Okay. I'm going to write you the formula here so that you can do 1 or 2 examples. Okay. For the first case just now, the Z is equal to P hat minus the P divided by. Okay, can everybody copy this? Then the second case, the test statistic is the Z is equal to the Z bar minus the mu divided by the standard deviation. This one is T. Okay, when you're done, copy this one. Type me done. Okay, done? Okay. Okay, we want to do one example here, okay? Let's go for this to share my screen. Okay, now spend some time to read this and get all the information you need, then we'll try to do it together. I'll give you about 2 minutes to do this. When you're done, until the end, you type me finish. I want to go to the pantry to take some water. So you try to do this. From the first step, you define your null and alternative hypothesis testing. And then after that, you draw your bell shape. Then you use the right formula. After that, you do the testing and compare, make conclusion. Okay. When you finish, you type me finish. Have you all finished? Okay. We do it together, okay? Is that okay? Okay. Okay, everyone, just put down your pen and then we do it together. Okay. The people have died in a boat accident because on the obsolete estimate of the mean weight of the man was used the weight of the simple random sample of men from the existing data will obtain this sample statistics. Okay, do we have the sample statistics here? N is equal to 40 and the sample mean is 172.55. Research from the several other resources suggested the population weight of the men have a standard deviation given of. Okay, use this result to test the claim that the men have the mean weight greater than 63. Okay, which was recommended the weight whatever. It's the tradition method. Okay. Okay. Anyone finish already? Okay, now can I have your attention and just put down your pen, just stare at the screen first. Okay. Yes, but not sure. It's okay, we discuss together so that don't miss it. Okay. So now we just write down the important information here first. Okay. The N is 40. And then the X bar, which is the sample mean, okay, is 172.55. Then the alpha is 0.05, significant level 0.05. And the standard deviation is 26. Okay, so now they're talking about proportion and they're talking about the weight. So what is the claim? The claim is talking about the man has a mean weight greater than 166.3. Okay, greater than 166.3. So our null hypothesis is forever, ever, okay, we're talking about the mean now, is equal to 166.3. And the alternative hypothesis here is the mu is greater than 166.3. Okay, greater. So the original claim is here. Later, when you draw the conclusion, you have to answer this question. Okay, so I can draw my bell shape already. By looking at this, I know my bell shape is here. It's one tail, it's right tail. Okay, right tail here. Okay, then I need to do my test statistics. Test statistics. Just now I give you another formula, right? The test statistics Z is equal to the X bar minus mu divided by the standard deviation divided by the square root of N. So I have this 172.55 minus this one. This one you don't know, right? It's not given, but it's in your null hypothesis. Always refer the population values here. So minus 166.3 divided by the standard deviation is 26, square root divided square root of 40. So anyone got these values ready? This is about 1.52. Correct or not? Yes. Thank you. Okay, 1.52. So after this, 1.52 means what? Means what? I need to compare already now. Okay, now they said the significant level, the benchmarking here, this is 0.05. This is 0.05. When 0.05, what is the reading here? Can anyone tell me what is the reading here? 0.05. So what is the reading? $1.96, is it correct? 1.645, 1.96, why? Why so different? Huh? The answer is 1.65. Yes, 1.645 also came. So this is 1.645. You have to know how to read this from the table for those who answer me 1.96 because this is one tail. This is one tail. We don't bagi our 0.05 to 2. One term only. Okay, 1.65. Okay, then I need to see this 1.52, where is it put? At the shattered area or not shattered area? 1.52 supposed to be somewhere here. 1.52. Correct. So because 1.52 is here, so we accept the hash now. But we cannot say we accept the hash now. So we fail to reject. We fail to reject hash now. Okay. Okay, not? With this, I already can make conclusion that we fail to reject hash now. Then our conclusion, how to write the conclusion? Because your clamp is here. So we need to put into our conclusion. So we said there is not enough evidence to support the clamp that because you fail to reject, right? Because you fail to reject. You fail to reject, that means this is correct, this is wrong. So we have to say that there's not enough evidence to support the claim that the mean weight is greater than 166.3. Can you understand me or not? There is not enough evidence to support what? The claim of this. Understand me? So far so good or not? Yes. Okay. Okay? Okay. Now, in chapter 10 here, we not only learn how to do hypothesis testing. Okay, I'm not going to cover the hypothesis testing for another one, which is the mean when the standard deviation of the population is unknown. I'll leave it for you to read because it's just used a different formula in the test statistic and also slightly different table. They're not using the Z table, but they use the T table. Okay, so that one I'll leave it for you to try by yourself because I want to cover a little bit on the confidence interval. Let me see. Where is the confidence interval? Confidence interval. Give me a moment how to find the confidence interval. Okay. Another one is talking about the confidence interval. Confidence interval. Confidence interval. Let me find the slide for a while. Confidence interval. Okay, now we back to this equation. Okay, we back to this question. Just now we're talking about the girl. This is the proportion question. Okay, so if you use the test statistics to do your test, so that is a called traditional method. If you use the p-values, okay, there's a few way. Okay, so if you use the test statistics formula, okay, then you compare with the critical values. You already can make conclusion you want to reject or you fail to reject H null. Correct, not? So after that, you can do conclusion. Correct. So this is hypothesis testing. Okay, are you with me now? Are you still with me?
Yes, madam.
Okay, so this method, if you use statistics to compare and then you make conclusion, this method is called traditional method. Okay, so another one is after you get the test statistic, okay, then you can get the p-values by reading the table. With these p-values, okay, you can compare it with the alpha, which is the significant level. Compare. With this comparison, you can make conclusion whether you reject or you fail to reject, okay, and you make the conclusion. And this method is called p-values method. Why I want to tell you so? Because sometimes the question will specifically ask you to use which method to do the hypothesis testing. If it is not, then it's up to you which one you want to use. So it's like you want to use test statistics to compare or you want to use a p-values. For this case, it's like you want to use a ringgit to compare with ringgit or you want to use USD compare with USD. Okay, so both will give you the same result. Okay, the other one, the third one, this is the third method. The third method is to use the confidence method, confidence interval method. So what is the confidence interval method? I give you the formula first here so that you know what I'm talking. Okay, the formula for the confidence interval, okay, for the proportion, you can write it down if you want because you don't have the step with you now. If you want for the proportion, the formula is P minus the E where your E is equal to Z alpha divided by 2 P hat Q hat divided by N. We will do one together, okay? Okay, this is the formula. We want to find the value of this. We want to find the value of this, and then we want to find what is the interval of the possible proportion for population. Okay, for example, I never go to that I never collect the data, but I only have the sample data. So when I sample data, I will predict what is the mean values or what is the proportion values because you are doing predicting. So predicting cannot be a specific number. Okay, so give yourself a range. So I think it's agak-agak from 160 to 165 contohnya. So this is to help you to find the range. Okay. Okay, the second one, the mean, okay, is all the head bar minus the E, mu, the head and the X bar, plus the E, where your E is equal to Z alpha divided by 2, standard deviation, if this is none. Or your E is T alpha divided by 2 S if it is unknown. Sigma unknown. It looks like a bit complicated, but actually it's very easy. Okay. Can you copy this thing down first? Then we try to solve this. Okay. When you're done, you tell me done so that we can go back to use the third method called confidence intervals. Confidence method. Done already? Okay, very good. Okay, so we go back to that question again before you forget, okay? So the question is talking about the pregnant woman keep guessing on the gender of the baby before they give birth, okay? So we have the proportion of the sample proportion is 57 out of 104. Okay, 57 guessed correctly out of 104 pregnancy. Okay, so now we want to find the confidence interval. Okay, so the confidence interval, the formula that I gave you just now is like this. This. So because now we are talking about the proportion, I will rub this thing off so that I can do the calculation with you. Okay. What do we need? We need to find the E first. We need to find the E first, then we can put our E into our confidence interval. Let me change the color. No need. Okay. So the E is to find the Z alpha divided by 2. In that question, they said the alpha is 0.05. So alpha 0.005, when your alpha is equal to 0.05, okay, I need to find the Z score when the alpha is, because it's divided by 2, 0.05 divided by 2, so I need to find the Z score of 0.025. Can you read from the table when your probability is 0.025, what is your Z score there? Anyone? Read from the table and tell me. 1.96. Yes, correct. 1.96. Thank you. So if I put it in, so is the Z alpha here is 1.96 square root of, what is your proportion, sample proportion just now? Sample proportion is 57 divided by 106, right? So it's 57 divided by 106. Then what is the Q? What is the sample Q? Sample Q is the fair one, the not correct one. So it's 47 divided by 106. Correct? Not? 57 plus 47 is 106. Correct? Okay. Divided by what? N. What is the N? 106. Can you calculate what is the E for me? What is the big E? Can anyone calculate what is the big E for me? .096. Okay. When you got this 0.096, then you can answer this question already. Okay. So the confidence interval, the CI, the confidence interval, is equal to this one. 57 divided by 106 minus 0.096. Okay. To 57 over 104 plus 0.096. So I get the interval of 0.45 until 0.64. Or you can write it in this way, 0.45. The P is 0.45 to 0.64. Okay. So the sample 57 divided by 106 is what? 57 and 104. Why I keep saying 106? The P is 0.548. Okay. Yes. Can I have your attention here? Can I have your attention here? Just put down your pen and just look at me. So this is method number 3, right? The method number 3, they always was ask you about your sample proportion. So you see your sample proportion now is 0.548, correct now? So you see this 0.548, is it in the range or not? Is it in the confidence interval range or not? The confidence interval range is from 0.45 to 0.64. So it is fall into that, right? It is fall into that. So this confidence interval, this confidence interval have 0.5. Sorry, we're not talking about this. We're talking about the P1. The P is 0.5. We're not talking about sample, sorry. So with sample 1 is 0.5. 0.5 is within the confidence interval. So when within the confidence interval, that means your null hypothesis is correct. So we fail to reject our H null. Are you confused? If you are confused, you type me you are confused. If you are good, you type me good. Confused. Okay, never mind. Never mind. So madam, as long as it's inside, is not rejected. Okay. Okay. To answer your question, so madam, as long as it is inside the confidence interval, is not rejected, is it? Okay. So what do you want to see? Yes, we use the confidence interval for us as a reference, but what is it? We always refer to your null and your alternative hypothesis. You look at your null hypothesis value, not look at the sample. Your null hypothesis in this case is 0.5. You want to see your 0.5 is in that range or not. If it is in that range, then we cannot reject. Use population proportion to see the interval or not. Yes, we use the population proportion to see whether it is in the interval or not. Okay, so a bit confused, right? Okay, now I stop sharing this one. Stop sharing. I want to share my whiteboard so that I can draw the conclusion to you. Where's my whiteboard? Okay. Okay, again, today we learn about, now everyone just put down your pen, just listen to me because I want to have the full conclusion about this. Then if you have question, you can just ask me. Okay, the thickness. Okay, so this chapter 10 is talking about the hypothesis testing. Okay, this chapter is talking about the hypothesis testing. Okay, the theory part, I will leave it for you to read it yourself. Okay, so what we test so far, we can test the proportion, we can test the mu when the standard deviation is none. Okay, the other one is also mu, but different technique where the standard deviation is unknown. Okay, now the question is how to do hypothesis testing on all these three things. Okay, they will not ask you to do the testing at three things at once. They will do either the proportion, do the mean, or the mean when the standard deviation is unknown. Okay, but these are these three things that we will cover in this syllabus in chapter 10. Okay, so there's a three to test this string. Okay, there's a three method. First one is to use the test statistics. Okay, number 2 is use the p-value. Number 3 is use the confidence interval. Okay, now this test statistics in a p-value, these two, they're having the very similar procedure. The first one, this one also need, okay? The first one, you need to define your H null and your H alternative. Number 2 is to do your bell shape. Number 3, you need to do your test statistic. Then you compare. Number 4 is you compare. Number 5, we have to make decision and conclusion. Okay, so what difference for this test statistic and the p-value is where you compare. only come into this step 4 when you compare. When the test statistic is test statistic compare with the critical values. P-value compare with the alpha. Normally alpha is 0.05. Normally, not all the time, but normally is 0.05. Sometimes they purposely change it to 0.1 just to make sure that you understand. But most of the time is 0.05. Okay. So what is this? Okay. Test statistics, when you do test statistics, you can easily transform this into the p-value. They're actually the same thing, these two. This and this, they're actually the same thing, just different form only. Because if you want to compare, you must compare ringgit to ringgit ma, or USD to USD ma. So if you use a test statistics versus the critical values, this is called traditional method. If you use the p-value versus the alpha, this method is called p-value method. Okay. If you use, okay, this is the method 1 and method 2. We done. Okay. Confident interval, there is a formula also. So what the main formula is to find the different E. So E formula for the formula for the P is different. For this is different. For this is different. Same as the case when you're using the test statistics. When you want to test proportion, the test statistic formula is different. Okay. So when you have the confident interval, you have to find the E. So after you find the E, you will find a range. You know what is range? For example, a range, or we call it interval in this case, interval. So for example, I said my TMF1874 students, their marks range from 55 to 75. You understand this, right? So means that all my student marks were only in this range. They will not go up to that range. So now the same case is that we want to find the interval value of what we're predicting. So if we are predicting, if we do the hypothesis for the P, let's say P is equal to 12 just now. The alternative is P greater than 12. Okay. So what you're predicting? You're predicting the proportion. So now in the critical value, in the confident interval, we are predicting the range for the proportion. Understand me or not? So this is the range for the proportion. So then when you want to draw the conclusion, you will see hypothesis testing here. Now hypothesis is talking about 12. So you look at the 12 is inside this range or not. For this case, 12 is not inside the range. So we reject the H now. We reject the H now. So far, so good or not? So what is this range tell you? This confident interval range tell you? This is to tell you that your normal range, acceptable range value of the proportion is within this to this. If it's outside this range, it's considered not correct. We want to reject it. Understand me? So far, so good, everyone. This is the conclusion, the whole story. If you can understand, type me understand. Okay. Very good. Okay. So now that is the things that because they are testing 3 different parameters, but they're using exactly the same procedure, the same way to do analysis. Just that you have to use the right formula to answer the questions. Okay. So that's the reason why I cannot go slide by slide how to do this. Okay. So as long as you know the procedure, you know which formula to take, then you should be able to answer it. Okay. But the in details, there is still some small thing, for example, type of error, why, what is the hypothesis testing means actually. I didn't explain to you in detail because I want you to get the whole picture first. So I still need you to go back to your slide and read your slide, try to do all the exercise in your slide and compare with your friends. If you don't really understand, then you can come back and ask me during the next lecture that you're going to see me. Okay, I will discuss with Dr. Izatu later on, and then we will make announcement in the Ellipse or in the WhatsApp group later on. So what we're going to talk about is that next week we're not going to have tutorial, and we're also not going to have lecture. Okay. So what to cover? And if Dr. Izatu said, why don't we have class next Friday? We will also announce in ellipse. So everything we refer to ellipse. Is that okay? Is that okay, everyone? Okay. So anyone, any more questions from you all? Yes, I
Doctor,
know,
sorry.
Nelson. Later we will upload the slide. We already have the slide there, just that we make it invisible for you all, so we make it visible later.
Doctor, sorry, doctor.
Yes.
The meaning of no tutorial, does it include the classes on Monday or only the classes that are involved for the holiday onwards? Or
Oh,
the
good
public
question.
holiday?
Good question. So the Monday is from which group? Who is the lecturer?
Mr. Pang, if I'm not mistaken, that is for group 6.
Okay.
NC
Dr.
students.
Pang.
Okay.
Okay. I will ask Dr. Pang to inform you all later on.
All right.
Do you all have the WhatsApp group with Dr. Pang?
Yes, we do.
Okay, good. Okay, any more questions? Sorry, I missed your question. Let me read it first. Yes, we will upload the mass lecture video later on. Doctor, for the table, is it okay if the value different be in the exam? Yes, it is acceptable. Since the table we use only have the account until second decimal. Yes, can. Not a big issue. Okay. Okay. Sorry, doctor, when exactly not having class? Okay. We're not going to have our lecture next week because of the gawai. I cannot do the manual attendance because this is not the class QR. We are using another way, so I cannot do the manual attendance for you because there's no record. Yes, sir, you just try one more time.
Doctor, can we leave, doctor?
Yes. If
All right.
no
Thank you,
question,
doctor.
then you can leave for a day. So bye. Take care, everyone.
Okay. Thank you, doctor.